Alright, hello everyone. This video is going over your dimensional analysis packet in pre-IB chemistry. This is a great review for the test on Friday, as well as good foundational knowledge for stoichiometry in the future. I went ahead and selected 10 out of the 16 problems in the packet, the ones that I thought were the most prevalent on the test and in the future in chemistry. So when we're doing problems like these, I always like to figure out what we are given and what we're trying to solve for. So number 1 says the distance from the Earth to the Sun is about 94 million miles. How far is this in kilometers? So we know that 94 million miles is our given, and kilometers is the unit we're trying to find. So ideally, we find an equality that has miles and kilometers in that equality, which in this case we do. So now that we have that, we can go ahead and set up the problem. So we are given 94 million miles. So that's 94 million miles. And the whole point of dimensional analysis is going from one unit to another. So since this is an equality, we can write a conversion factor as 1 mile over 1.6 kilometers or 1.6 kilometers over 1 mile. And that's all going to depend on what unit you want to cancel out. So in this case, we want miles gone and we want to end up with kilometers. So 1 mile is going to go on the bottom so that our units cancel out. And then 1.6 kilometers goes in the numerator, so we end up with kilometers as our unit. So now since all of our numbers are in the numerator, we're going to go ahead and multiply 94 million times 1.6. When you do that, you get 150,400,000 kilometers. And then it says write your answer in scientific notation. So since we have a number greater than 10, we know we're going to have a positive exponent. And then to figure out what that exponent is, you're going to move the decimal point to the left until you get to a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8. So our final answer in scientific notation would be 1.504 times 10 to the 8th kilometers. And then I know on the board I also showed it when you put 94 million right into scientific notation from the beginning. I'm going to show you that way just in case you'd rather do the math that way. So we can also start with 9.4 times 10 to the 7th miles and do the same conversion factor. And when you do it this way, I recommend just multiplying the coefficients first. So you'll get 9.4 times 1.6. That gives you 15.04. And then you're going to attach on your exponent that you were given. And then since this is not in scientific notation, we're going to move it 1 time to the left, add to the exponent, and that would give you the same answer that we got earlier at 1.504 times 10 to the 8th kilometers. And honestly, it doesn't matter which way you do it. As long as you get the same answer and you're using the same conversion factor, that is good for me. All right, number 2, the average human lives 74 years. How many days is this? And how many seconds? Write your answers in scientific notation. So I'm going to go ahead and do the second question, how many seconds? Because I did days in class and it's just kind of simple, I want to do the harder version. And so you can see a more linear pathway. So again, let's figure out what we're given and what we're trying to get to. We are given years and we're trying to get to seconds. So these equalities are more known to the average human. So like years to days, days to hours, hours to minutes, and then minutes to seconds. And we can use that to get all the way from years to seconds. So again, let's start with what we're given, 74 years. We know that in 1 year, we have 365 days. We know that in 1 day, we have 24 hours. We know that in 1 hour, we have 60 minutes. And we know that in 1 minute, we have 60 seconds. And you could tell that I just kept going until I got to my desired hour. Since it's time, we'd use this a lot, so it's very easy to come up with. And then all you want to do before you start solving is just make sure that your units are canceling out. So remember, to cancel something out, it has to be in the numerator and in a denominator. So years is gone, days is gone, hours are gone, minutes are gone, and we're left with seconds. So our final answer is going to be in seconds, which is what it asks for. And then you'll notice that everything in the denominator is a 1, so we're not dividing by anything. Everything is going to be multiplied. So in your calculator, do 74 times 365, press equals, times 24, press equals, times 60, press equals, and then times 60 again. That's going to give you, at least on my phone, 2.33366 e to the 9th. That's just telling you that it's 2.33, let's round it to 4, times 10 to the 9th seconds. And if it did not give it to you in that form, you can just move the decimal point until you get to a number between 1 and 10, which in this case would be 2.3. And then when it asks for how many days is this, you would do this exact same thing. You would just stop here. That's why I wanted to show you the longer version. All right, number 3, a hummingbird can beat its wings up to 90 times per second. How many times will it flap its wings in an hour? So this is really important because you don't just have seconds, or you don't just have ounces, or you don't just have gallons. You have something that is times per second. So that is 2 units, even though times isn't really something that we use a lot, but it's still a unit of measurement here. So we have 90 times per 1 second. So that means in 1 second, the hummingbird beats its wings 90 times. So that's what it's giving you. And it's asking you how many times will it beat its wings in an hour. So we do not want to get rid of times because we're still trying to solve for times per hour. We're just trying to get seconds to hours. So in order to get seconds to hours, let's first go seconds to minutes. We know from our previous that in 1 minute, we have 60 seconds. And then in 1 hour, we have 60 minutes. So now you can see that our seconds are going to cancel each other out. Our minutes are going to cancel each other out. And now our unit that we're left with is times per hour, which is exactly what it's talking about. So times per hour. So now, again, everything on the bottom is 1. So all we're doing is multiplying. So 90 times 60, press equals, times 60, press equals, you get 324,000. So now we're going to put that in scientific notation. So we're going to move the decimal point 1, 2, 3, 4, 5. So our final answer will be 3.24 times 10 to the 5th times per hour. All right, the average peanut weighs about 3 grams. How many peanuts will an elephant eat in a week if it eats 5 kilograms of peanuts a day? So in order to solve for this problem, we need to find out how many grams of peanuts an elephant eats in a week. Then when we figure out how many grams of peanuts it eats in a week, we just divide it by 3 grams, and that will give us how many actual peanuts that it eats. So we are given 5 kilograms a day, and we're trying to get to grams a week. So let's start with what we're given. So we have 5 kilograms in 1 day, and we're trying to get 2 grams per week. So you can pick which one you start with. It honestly doesn't matter. I'm going to go ahead and start with grams. I know if I think about King Henry died by drinking chocolate milk, I know in order for me to get from kilograms to grams, I have to multiply by 1,000. So in 1 kilogram, I have 1,000 grams. So in 1 kilogram, I have 1,000 grams. And remember, this is a conversion factor. So it can be 1,000 grams over 1 kilogram, or it can be 1 kilogram over 1,000 grams. The only difference is what you want to cancel out. Now, in this case, I want to get rid of kilograms, so I need kilograms on the bottom and grams on the top. So now I'm in grams per day, and I need to be in grams per week. So I'm already in grams, so I need to focus on changing day to week. And I know that in 1 week, I have 7 days. So now if we look at our units, kilograms is gone, days are gone, and I'm left with grams per week. So grams per week. And now I can go ahead and do the math. So I have 5,000 times 7 is going to give me 35,000 grams of peanuts in 1 week. So now in order to find out how many actual peanuts that is, I'm just going to divide by 3. And that's going to give me 11,666.67 peanuts per week. And this next part is a little bit ahead of the game. It's not on the chapter 1 test, but I'm going to tell you anyways. If you look at the numbers that are given to you in the question, each of them are only 1 sig fig. So you're going to assume that you want to answer in 1 sig fig. So if we wanted to answer 11,666.67 in 1 sig fig, we'd cut it off after the first. And then 1 does not round up. So we'd end up having 10,000 peanuts per week. This is a great example of why scientific notation is going to lead to a precision in your data, because if you look at this, 10,000 peanuts per week is much different than 11,666 peanuts per week. So even though in terms of rules, you would answer in 10,000 peanuts per week, it's not necessarily the most accurate way to answer. All right, number 5, what is the density in grams per centimeters cubed of a bar of gold that has a mass of 2 kilograms, a length of 80 millimeters, width of 40 millimeters, and height of 36 millimeters? So again, let's figure out what we're trying to get to and figure out what we're given. So we know that we're trying to get to density, and density is grams per centimeters cubed, and we are given kilograms, and we are given a length, a width, and a height, which we know is volume. Now, our volume that we want needs to be in centimeters cubed, and if we multiply all of these together, we would end up getting millimeters cubed. So when we're solving for volume, we need to change our millimeters into centimeters. And if you use King Henry died by drinking chocolate milk, we're in millimeters and we need to go to centimeters. So we're just going to move it 1 time to the left. So that would give us 8 centimeters times 4 centimeters times 3.6 centimeters. And then when we multiply those together, 8 times 4 times 3.6, that's going to give us 115.2 centimeters cubed. And now let's go ahead and try to solve for density. So density is going to be grams, we have kilograms right now, over centimeters cubed, which we just solved for. So now we need to convert 2 kilograms into grams. And we know that in 1 kilogram, we have 1,000 grams. If you can't get this equality from King Henry died by drinking chocolate milk, I highly recommend memorizing that so that you don't get caught up or get an answer wrong just because you don't know the equality. So again, if you cannot get it from King Henry died by drinking chocolate milk, please just memorize that in 1 kilogram, you have 1,000 grams. Okay, so then that would give us 2,000 grams, which would be our numerator. And then from there, you can see that our unit will be grams over centimeters cubed, which is exactly what it asked for. So we would do 2,000 divided by 115.2. That will give us a density of 17.36 grams per centimeters cubed. And that's your final answer. All right, write the following numbers in scientific notation. Again, we're just moving the decimal point until you get to a number between 1 and 10. I'm just going to do the first 3 for you. I feel like you guys are pretty good on this. So the decimal point's here, 1, 2 to the left. It's a number greater than 10, so it's going to be a positive number. So 1.23 times 10 to the second meters. Don't forget your units. Again, same thing here, 1, 2, 3, 4. It's a big number, so we're going to have a positive exponent. And don't forget our units. This one is a number less than 1, so we're going to move the decimal point to the right. And it will be a negative exponent, so 7.08 times 10 to the negative 2. And again, don't forget your units. All right, 8. Convert 3,598 grams into pounds. Okay, so I know that I'm given grams, and I know that I need to get to pounds. The closest equality I can find on this is pounds to kilograms. And then I already know my equality for kilograms to grams, or vice versa, which is 1 kilogram is equal to 1,000 grams. So now I can go ahead and solve. So 3,598 grams. I want to get into kilograms first, so I can go from kilograms to pounds. So I know that in 1 kilogram, I have 1,000 grams. And now I can go from kilograms to pounds. And if you look at my units, everything should be gone besides pounds. So grams canceled out and kilograms canceled out. I'm left with pounds. And I do have a number in the denominator here, so I am going to have to divide by 1,000. So in my calculator, I do 3,598 divided by 1,000, press equals, and then multiply by 2.2 since it's in the numerator, and I get 7.916 pounds. All right, convert 231 grams into ounces. So I am given grams, and I am going to ounces. So I know that I have ounces here, but it takes me to pounds. And I know I can take pounds to kilograms and kilograms to grams. So these are going to be the 2 equalities that I'm going to be using for this conversion. So we're going to start with what we have, which is 231 grams. And I know to get started, we're going to have to get to kilograms. So we're going to do that first. In 1 kilogram, I have 1,000 grams. Now I can go from kilograms to pounds. So I know in 1 kilogram, I have 2.2 pounds. And now I can go from pounds to ounces because I know in 1 pound, I have 16 ounces. So now if I look at my units, everything should be canceled out except for ounces. So grams are gone, kilograms are gone, pounds are gone. So I'm left with ounces. And then I do have one thing in my denominator, so I do have to divide that by that. So 231 divided by 1,000, press equals, multiply by 2.2, press equals, and multiply by 16. That's going to give me 8.13 ounces. All right, how fast is 65 miles per hour in kilometers per second? All right, so I have miles per hour, and I want to go to kilometers per second. So we know how to get from hours to seconds at this point. We need to make sure we can get from miles to kilometers, which will be easy because we have this equality here that has both of them in there. So now let's start with what we have. So we have 65 miles in 1 hour. And we want to go from miles to kilometers and from hours to seconds. So we know that in 1 hour we have 60 minutes. And we know that in 1 minute we have 60 seconds. And now I'm in seconds, so I can go ahead and focus on kilometers. So I want to get rid of miles, so 1 mile is going to be on the bottom. And I want to end up with kilometers, so 1.6 kilometers is going to be on the top. So now let's look at our units. So miles are going to cancel out, hours are going to cancel out, and minutes are going to cancel out, and we're left with kilometers per second, which is exactly what we're looking for. Kilometers per second. And just so you know, you'll also see something like this written like this as well. This means the same thing. It just means that we brought seconds up to the numerator, so now it has a -1 exponent. Just as a little side note. So now we do have values on the denominator, so we're going to have to divide in those cases. So we have 65 divided by 60, press equals, divide by 60, press equals, and then multiply by 1.6. That's going to give us 0.0289 kilometers per second, which is your final answer. All right, so our last one for this video is number 16. It says that gas costs $3.45 per gallon. How much money will you spend if your car has a 35-liter gas tank and you're filling it up? So we are given dollars per gallon, and we want to know how much money it costs to fill up 35 liters of a gas tank. So the first thing we need to do is get from dollars per gallon to dollars per liter, and then we're just going to multiply by 35 to tell us how much money it would cost. So again, we're given $3.45 per 1 gallon. We want to see what it costs per liter. So we're using our equality up here. 1 gallon is equal to 3.785 liters. That is going to give us our answer in dollars per liter. So you can see our gallons are gone. We're left with dollars per liter. And that's going to be 3.45 divided by 3.785, which will give us 0.9115 dollars per liter. And now since we know that the gas tank is 35 liters, we can just multiply this by 35, and that will tell us how much money it would cost to fill up the tank. And when we do that, we would get $31.90. All right, I hope this video helped. If you have any questions, please come by my room at 5324, and I'm happy to help. Have a great day. Go Rams.